Okay, so here's this problem. How long does it take a car to cross a 30-meter wide intersection after the light turns green if the car accelerates from rest at a constant 2.00 meters per second? Okay, I'm going to say I don't know how to solve this problem, but I do know a strategy that will lead me through this if I let it. And I'm going to start with that strategy and draw a motion diagram to collect all my information on. Okay, so my origin and my direction of positive x values, and I'm going to ask what's my initial position. As it happens many times, it's going to be 0 meters because I'm told that I don't have an initial position, so I'm free to set my own. If I go 30 meters, my final position is going to be 30 meters. Okay, my initial velocity, I start at rest, so I'm going to be at 0 meters per second. And I don't know what my final velocity is. I haven't been told that. But I do know that I'm going to do this. Okay, I'm going to increase in velocity. So I know that my acceleration arrow is also going to be in the positive direction, the direction of increasing velocity arrows. And I've been told that I accelerate at 2.00 meters per second squared. Okay, there's nothing here other than collecting information. I didn't have to know any problem-solving strategy. I didn't have to discern anything. I just got the information. And now I'm going to write that down in a standardized way. Given x0 equals 0 meters, x equals 30.0 meters, that's my final position. My initial velocity is 0 meters per second. I don't know what my final velocity is, so I'm not going to write that down. I know that acceleration is 2.00 meters per second squared. Now in this case I don't have time, but I do want time. Okay, so my need is going to be t. So I can't use that last formula. My first question is, do I have time or do I need time? And if I say yes, then I can't use that last formula. My second question is, do I have an acceleration or a constant velocity? And I don't have a constant velocity, so I also can't use x equals x0 or x equals x0 plus vt, right? But I can use this third equation because I don't have a final velocity, so that means I have to use x equals x0 plus v0 times time plus 1/2 at squared. Now, I know by inspecting that my initial position is 0 and my initial velocity is 0, so 0 times time is still just going to be 0. So both of those drop out, and that leaves me with x equals 1/2 at squared. Well, I want t, so I'm going to isolate that first, and then I'm going to solve. So I'm going to multiply both sides of the equation by 2. That'll give me 2x equals at squared, and then I would divide by a, and that would give me 2x over a equals t squared, and then I'm going to take the square root of that. So I know that t equals the square root of 2x over a. And then I'm going to write solve. And I'm going to say t equals, and I'll put my values in, 2 times 30.0 meters. Okay, let's make that a better m. Divided by my acceleration, which is 2.0 meters per second squared. And time will now be, and those 2's will cancel out, and so I'll have the square root of 30. And that will give me 5.48 seconds. 0.48 seconds. Okay, and that solves that problem. Okay, again, notice I did not have to do anything in the way of thinking. I just followed this process. I collected my information on the motion diagram, x0, x, v0, v, a, and I wrote it down in a standard form here, and then I said, oh, I need time, and then I asked my questions. Do I have time or do I need time? Yes, I can't use that last formula. If I got an acceleration or a constant velocity, I've got an acceleration, I can't use that first formula either. And do I have a final velocity? No, I don't have a final velocity. This is the formula I have to use. And I just plugged the values in and solved it. Okay, there was no thinking required. So let's move on to